This video lesson is on quantitative electrolysis calculations. This is coming out of chapter 20. And so we're going to look at how to handle some of your electroplating problems. A couple of conversion factors you want to understand and know, remember, that we will use for these type calculations. First of all, 1 amp second, so 1 amps times seconds, is equal to 1 Coulomb. Also, remember Faraday's constant from the Nernst equation. 96,485 coulombs are equivalent to 1 mole of electrons. And then also from our last class, we learned that 1 volt is equal to 1 joule per coulomb if you break down the volt and from its derived units. Okay, so let's take a look at number 1. This problem wants us to calculate the number of grams of aluminum that would be produced in 2 hours by the electrolysis of molten aluminum chloride. Now, one thing that you will need to do for this particular problem is understand that aluminum chloride, its formula is AlCl3, and that would be a soluble salt. So you need the redox reaction or the reaction taking place with the with respect to the electrons. So if this were to break apart, the ion here, the metal ion, you could write aluminum solid yields the aluminum plus 3 ion plus 3 electrons. So there's your oxidation half reaction. And we need this because we're going to need to relate the moles of electrons to the moles of the aluminum or the aluminum ion. Okay? So let's start with our given. And then we're going to use some of our conversion factors to help us get through this calculation. Now keep in mind, we're looking for the number of grams of aluminum. So you're looking for grams of the aluminum solid. And some things that we were told. We were told that 2 hours will pass by. They want to know how much you will produce in 2 hours. And they've told you the electrical current, the amperage here, 12 amps. So I'm going to start with the 12 amps here. So 12.0 amps. We're going to use some dimensional analysis to convert. Now, ultimately, what I'm going to get to, and this is going to be kind of a lengthy conversion here. We're going to do it all in multiple steps here in one problem. But we're trying to get to the grams of solid aluminum. Not the aluminum ion, but solid aluminum. So we need to somehow go from amps to grams, and we're going to use these conversion factors as well as some molar masses and some time factors that we know. So let's see what we have here. We were told here that 1 amp second is equal to 1 Coulomb. So we need amps to cancel, so let's use that on bottom here. 1 amp second is equal to 1 Coulomb. So what that's going to allow us to do is it's going to allow us to get amps to divide out. So now we have coulombs per second. So the next thing that you want to keep in mind is you see they gave us that 2 hours are going to pass. So we need to somehow get our time unit into hours. So let's think in terms of getting this unit to cancel. So we need seconds to cancel out. Since it's on bottom here, I'm going to need it on top, seconds. And we know we can relate seconds to minutes because we're trying to get to hours here. So if you think of the relationship between seconds and minutes, we know that 1 minute contains 60 seconds. This will allow you to get your seconds to divide out. Now we have coulombs per minute. All right, we need to get to hours because we're going to have to use that 2-hour time period. So we need minutes to cancel, so it needs to go up here so that it will divide out. We need them to be diagonal to cancel. So we can relate minutes to hours. We know that there are 60 minutes in 1 hour. This is going to allow minutes to divide out. So right now, the units we have are coulombs per hour. Now, we know that the time period that's going to pass by is 2 hours. So since hours is on bottom here, and we need to use the time factor of 2 hours, we're going to put the 2 hours. I know that was one of our givens, but what we're doing is trying to get our units to cancel out and using the information they're giving us. So we need 2 hours to cancel. So I'm going to put 2 hours here, and that's going to allow the hour to cancel with the hours. So nothing's going to go under this because we just know it's a period of 2 hours. All right, now keep in mind, ultimately, we're trying to get to the mass of aluminum that will plate out. Look at the units that we have currently. Right now, the only unit that we have that hasn't canceled is coulombs. So let's work on that unit now. So we know that as far as coulombs go, we can relate with Faraday's constant. We know that 1 mole of electrons is equal to 96,485 coulombs. So we're going to use that next. So we need coulombs to divide out. Since it's on top here, we're going to come all the way down here and put coulombs. 96,485 coulombs is equal to 1 mole of electrons. I'm about to run out of room. I didn't leave myself quite enough room here, so let me try to extend this. Now, this is letting coulombs cancel. Now, in the end, we need just grams, and so that's why I've got to get all of my units converted. Now, this is where I need this reaction. So we need moles of electrons to cancel. So moles of electrons we can put on bottom here, and that's going to come from the mole ratio from this balanced equation. There are 3 moles of electrons transferred here. And now we can relate that to the aluminum metal. So there's 1 mole of aluminum, 1 mole of aluminum ions, and 3 moles of electrons. So we'll put 1 mole of aluminum here, the metal. This is going to allow your moles of electrons to cancel here and here. All right, almost there. So we have moles of aluminum. We've converted to that, but we need to go to grams. So you need to consult your periodic table and get aluminum's atomic mass. So the atomic mass of aluminum is 26.98 grams per mole. Okay. Now this is letting the moles of aluminum cancel, and we have grams, and that's what we wanted. So now we're ready to plug it into our calculator. So you're going to multiply 12 times 60 times 2 hours times 26.98, and then you're going to divide that by 96,485, and then divide it by 3. Now, as far as our sig figs go, we had in our given 3 sig figs in the time that was given and 3 sig figs in the amperage that was given. So we're going to need 3 sig figs in our answer. So for my answer on this one, when you plug that in, I got 8.05 grams of aluminum will plate out in that process. All right, let's move on to example 2. For example 2, it says the half reaction for the formation of magnesium metal upon electrolysis of molten magnesium chloride is Mg2 plus 2 electrons yields magnesium. So they've already given us the reaction here. Wants to know how many seconds. This is what we're looking for. So we're looking for a time. How many seconds will be required to produce 25 grams of the magnesium from the magnesium chloride if the current is 50 amps? Okay, so we're looking for seconds. That's our question mark. So in the end of the problem, we're going to be finding seconds. So we're going to start here. I'm going to start with the mass. So 25.0 grams of magnesium. And again, we had 25.0 grams of magnesium was formed from the magnesium chloride. So they gave us the grams of magnesium. So we're going to plug and chug away at our units until we get them all to cancel out. So we need grams of magnesium on bottom. This will be our molar mass of magnesium. Look at your periodic table. 24.31 grams per mole. So that gives us moles of magnesium. Now we can relate the moles of magnesium to the moles of electrons. So according to the reaction, 1 mole of magnesium will produce 2 moles of electrons. So this will let your grams of magnesium divide out and your moles of magnesium to divide out. Now we can use Faraday's constant because it has moles of electrons. So we know that